Okay, let's start, guys.
Ayan.
Yes.
Boy, after this boy, bala ma rek nga call ma boy ñu wax boy.
All right, no problem.
Am nañ meeting ak ministre bi sax léegi nii lañ pare.
But after ni boy, man mangi gena de boy. Ti badde suma
Non
jabar
non
la
non
de
waaye
boy.
benn 5 minutes spare ma 5 minutes rek dee bro yow tam ah ku la bay
Okay.
yow tam bu
Mangi
lee
dem
dox di
de.
lox yow tam ah.
Right. Okay. Guys. I mean, this is a simple lab we will do for Ethernet for layer 2. In this lab, we will demonstrate how does a switch learn, the MAC address and populates its own MAC table. Like I told you, the switch has a table called MAC address table. So for you can pay attention here, Comfort. If you look where my cursor is pointing at, that's a symbol of a switch. Behind that one, this is a router, this is a switch, and this one is a hub. So we are not using hubs in this. These are legacy devices. But mainly we will concentrate on these two, a router and a switch. So if you want to select a switch, you click here, then you will see different types of switches here. Then you can choose the 2960 here, click on it, and then move the cursor here, click inside. You see, that's a switch. So, okay, all right. So after that, we want to take N devices. You can see a sample of N device here. These are laptops. Click here, then you see the different types of N devices. There's a PC, a laptop, a server. So we just choose different laptops. If you want to choose more than one laptop, and to make life easy for yourself, before you click on the laptop, hold the control button, hold it down and click the laptop. Then you can see, in that way you can choose different laptops. Are you following?
Yeah.
So that is done. Now this one, this symbol is the connection one for the cables. Like we said, when we are connecting unlike devices, you know, a switch and a laptop are unlike devices. A laptop is a host device, a switch is a network device. So when we are connecting the two, we use a straight through cable, right? So this is an example of a straight through cable, you can see. This one is a crossover cable. Okay, so here we need a straight through cable and we need many straight through cables. So just press the control key and then select it. Now, if you click the switch, you see all the 24 ports of the switch. So you can choose any of them. Let's say I connect this one to port 1, and then you connect it to the fast Ethernet port.
Yeah.
Then go back to the switch again, click. Now port 1 is used, so you can see port 1. Now we use port 2. Connect this one to port 2. Same thing, use port 3, and on. Please, when you get to the device, don't try to connect to this USB because this is not the right port. You cannot connect to it. So you have to connect to the Ethernet port, fast Ethernet port. You see? Now this is our topology. And I told you, for any network, for the network devices to communicate, you must have the source and destination IP, source and MAC IP, source and destination MAC address. You must have this. You must have source and destination IP address. You must also have source and destination MAC address. The IP addresses are regarded as the logical logical addresses, and the MAC addresses are the physical addresses. And I told you every device, hardware, every device that communicates must have a MAC address. You understand? And I gave you a demo on my own, but we can go to the Windows because these are an example of a Windows machine. If you go to the command prompt, I don't know if this is clear. Type IP config /on. You see the MAC address. You can see it written here. I don't know whether I have to zoom this for you. Do I have to zoom this? What is working for Zoom? But my Zoom, okay, it's not going. I don't know. But is it clear? Can you see it written here? Physical address. You see?
Yeah.
Is it clear?
Yeah.
So that is the physical or the MAC address of this computer. But you can see when we type IP config, there is no IP, the IP address, because we did not configure IP address, you can see. IP address information is 0.0.0, but we did not configure IP address yet. Okay, but the computer is going to come with the hardware address from the manufacturing company. So that is why the physical address or the hardware address is always there. So let's close that one. You go out. I don't know. I don't want to disturb. So that is it. So now, this is an example of a local area network. So only one network can be here. But you will not understand that part very well because we have not get into subnetting yet. But one thing you do is, to give this computer IP address, you have to click the computer, go to IP configuration, and you give an IP address here, 192.168, sorry. You can give an IP address here as in 192.168. Let's say 10.1. And you press the tab key. When you press the tab key, it is going to automatically give you this subnet mask. This subnet is the default subnet mask for class C IP address. This is an example of a class C IP address. So this is a default subnet mask. So right now we don't need a default gateway. We are done with this computer. So we can move to this computer also. Go to desktop IP configuration and then give another IP address. Dot 10 dot. What was the IP that we gave to the first computer?
10.1.
10.1. 10.1, yes. We gave it 10.1. Okay?
Okay.
So this one, you have to give it 10.2. If you give 10.1, what is going to happen is, there is going to be an IP conflict. Let's put 10.1 and you see. You see there is a warning here. IP address already in use. So two computers in the same network cannot use the same IP address because IP address uniquely identify that computer. So
the name.
Yes, it's uniquely identified in the network. Okay, so we have to give this one 10.2. Sorry, and then you press the tab key. It is going to give you the default one, 192.168.10.
So young, this is IPv4. Huh?
Yeah, this is an IPv4. It's a class C IP address. Further later in the course, we will see different classes of IP. You have class A, class B, class C, class D, and class E. You see all the ranges. So this is an example of a class C IP address. But this is a private IP address also. We'll look into all that. We have public IPs and private IPs. Okay, so we move to the other computer now. Go to desktop, IP configuration 192.168.10.3. Okay, we give this one. Let me see if, okay, somebody is waiting. Yes. So again here, IP configuration 192.168.10.4. Okay, so done. Let's go to the final computer.
So you would not save Youngs.
Yeah.
It automatically saves, right?
Yeah, because this is just a simulator. Maybe if you're using your real computer, I don't know, maybe there is a button to save here, but it's closed. So this is 192.168. What was the last one we used? Is it 5 or 4?
4.
4. So this is 5 now. 192.168.10.5. So this is done. So all our computers have IP addresses. But right now, normally, like the switch is responsible to forward information. You know that, right? But right now, if you look at the switch did not learn anything from the computers. So that is why one of the slides says switch learning and forwarding procedures. Now let's open the switch. If you want to open the switch, you just click on the switch. This is how the switch will look like. First, let me increase the font size here. I go to option, preferences, font, and the CLI, I move it to 16. Apply it, and then close it. So I want to use the switch. Let me click on the switch. This is the switch. You can see the port on the switch here. Can you see it clearly? Okay. So, but I want to access the CLI, that is the command line interface. I click on the CLI. This is the CLI. You can see this is the prompt of the switch. Are you guys following?
Mm-hmm.
So at this moment, the prompt here we are the user execute mode. We have to type the command enable.
Yeah.
We have to type command enable to take us to privilege mode. We are in the privilege mode now. From here, we can use most of the commands, the show commands. Like if I want to look at the clock of this switch right now, I'll just type show clock.
Okay.
So this clock of this switch is right now 1st of March 1993. Okay. This clock, the time is 1993. So we need to change the clock to the current time. So to change the clock, which the command is what?
Set clock.
I think
Set up or set?
Is it, sorry, clock set, clock set. Then you can use the question mark if you don't know the full command. Okay. You can use the question mark to tell you, now we need to enter the hour. Right now is 12, or let's say 1300. Okay. Then after the hour is the minutes. Let's say is minutes, let's put 00, and seconds we also put 00. That is done. The next thing we need to enter is the month. This is what? September, right?
09.
No, you can put this September, sorry, as in this. And then today is 03. Okay? And is 2020. So this is the full command to set the clock of your router or your switch. Every device, your switch and your routers, you need to put a correct timing on them. It's very important because the switch or the router will maintain something called logs files. So anything that happens in the network is going to be entered in the log file. So if you come to check the log file, you have to see the correct time. Imagine that today something happened and our switch time is 1993 and it's telling us this thing happens in 1990. Will it make sense to us? No. So the switch must have a correct time. So now we have a correct time. Let's look at our correct time. So clock. You can see. Now we have a correct time. Okay? Is that okay? So let's look at our MAC table. So MAC hyphen address table. But let me clear.
So MAC is what? Okay, MAC address, huh?
Yes. MAC address table. Let me clear it because normally there should not be there, but because the switch, because sometimes they will send some information among them. But if you look at the so MAC address table, you realize that the MAC address table right now is empty. Do you see? There is no MAC address, there is no port labeling, it's empty. Okay? It's empty, right? So what we do is, let's go here and start sending packets. Like I told you, for instance, if we are in the classroom.
Wow.
Okay, good. So like if this is a classroom, for instance, the first time you want to communicate, look at this, I told you, the first time they will communicate, they will send a broadcast message. Sir, a lot of noise is coming from yours. Can you mute yourself, sir? This is so important that I want you to get it.
Okay.
All right, guys. If you're following, like I want to send a packet from this computer to this computer here. And this is the first time they are communicating. But this computer will know the IP address of this computer, but doesn't know the MAC address. So the first time they are communicating, this computer is going to send a broadcast. What is a broadcast? One computer sending messages to the rest of the computers in the group. That's called a broadcast. So let's simulate that. Now we try to send a message. I'll play with this. You can see now the message is traveling. It's a broadcast message. but only the intended computer will reply. You can see all the computers got, but they have labeled it X. That means they have dropped it, except this computer. So this computer is the only one that is.
Why is it that all the computers are labeled X without that one?
Yeah, because the message is intended for this one only.
Yeah, for that
So how did you send it? It's like you've inserted the MAC address of that computer?
No, because we don't know the MAC address. We only know the IP address. Just for instance, if we are in a classroom, I just walk into the classroom. I want to talk to Setijan, but I don't know who Setijan is. If I'll just shout in the class, Setijan, and everybody will get the message, right? But only Setijan is going to say yes.
With respond, yes, you are right.
You understand? You understand?
Hey, that's a very bright example, bro.
So like if you remember, I told you about this protocol. You can see address resolution protocol. So this computer is using address resolution protocol to be able to get the MAC address of the computer by sending the IP address. Okay. So now, if we let's close this now. Let's go to the switch now, guys. Look at this. Let's go to the switch now and type. You can see only two computers are able to communicate successfully, and the switch have learned their MAC address and their corresponding ports. You understand? Hello, guys.
So FA0, okay, that is it different from here? No.
Fast
Is
Ethernet.
it GI0 port 1?
No,
like
this FA stands for Fast Ethernet 0 port 1. The 0 is a module and the 1 is the port number. The 0 is the module. Like you can have a switch that is 24 ports, and then you add another 24 ports there to become 48 ports. So those two ports, those first 24 is going to be on a one card. So that card is going to be 0 module. So the second module you bought is going to be module 1. So that is why you will see Fast Ethernet 0/1. If it is in the second card, you will see Fast Ethernet Fast Ethernet 1/1. Are you getting me?
Yes.
Okay. So now you can see only these two MAC addresses are learned in this computer. So now let's walk around with this other two. Okay. Take an envelope, this envelope, drop it here and drop it here. Go to simulation. You can see, play with it. Guys, where are you going? But in whatever cases, you will see another MAC address is going to be LAN, because these two computers will also start communicating. Okay, now let's go back to our switch. That is how the switch will land the MAC address. You can see we have another additional MAC address that is connected to port 4, port 1, port 2, and port 5. Okay, so now, when everything is done, where are we? Let me minimize or close this. Okay, real time. So when we send communication to all of them and everybody, we have 5 computers, right? So you will see that we'll be able to have at least all the 5 MAC addresses are here now. So you can see 1, 2, 3, 4, 5. Now the switch is able to learn that. Let's say this guy is Setijan here. That is the MAC address of Setijan's computer. The switch is able to learn that Setijan is connected to port 3. And let's say this is the MAC address of Comfort's computer. The switch is able to learn that this is the port that this guy is. So the next time Setijan wants to talk to Comfort, Setijan will not send a broadcast. It's going to send a unicast address, because the switch understands the port that Comfort is connected to.
Yep, that's okay.
Directly. Okay.
Wow. Understand?
So, okay.
The example I gave in the classroom scenario.
Okay.
You know, when I meet you guys first time in the classroom, I will yield Setijan's name. The moment Setijan answered, I will recognize his face, I will know Setijan. So the second time I need Setijan, I will not yield his name. I'm going to walk to Setijan straight and talk to him. You understand?
Well, your volume is getting low now.
Oh, sorry about that. How is it now? Hello?
Better.
Much better. Okay. So what I was saying is, the example I gave you, if the first time I walk into the classroom, I don't know Setijan, I will yield his name, broadcast. If he answers, I'll be able to recognize him. And the next time I need Setijan, I don't need to shout his name. I have to walk to Setijan and talk to him.
Okay.
So that is
That
what
is
is
like,
happening.
okay. That is like sending with an IP, and
Yes,
this time.
yes. This time I'm sending
Okay.
with full information because I now know Setijan.
Mm.
Yes. Just like I want to come to your house, but I only know your telephone number. That is the IP address, for instance. But I cannot come to your house only by knowing your telephone number. I have to know your address too. That's your physical address. So what I will need to do is, I'll have to call you on the phone. Hey, say, I want to come to your house. Where are you? Okay, I'm in Bundun 6 Johnson. So now you have given me your hardware address. So I'm not full details, so I can come to your house, right? So that is all now. So to remove the MAC address table, you can type the command clear MAC -address table. The switch is going to erase everything, and the switch is going to start learning new again. If you look at the MAC address, it's empty now.
Okay. Clear MAC, okay.
Clear space MAC -address table is going to remove the table.
Yanks.
Yeah.
Yanks.
Yeah.
This VLAN here.
Yes.
You know, it's like, okay, I just want to, I think, but it's the same thing.
No, we will get to VLAN. Don't worry. Like I was explaining, your scenario is if you are connecting both GRTS and Moisey on the same switch, but they are on a different network, you have to create a VLAN. To check the VLANs, you type command show VLAN. This will show you all the VLANs. You can see by default, you have only one default VLAN is VLAN 1, and all the ports of the switch are connected to that VLAN.
That are active.
Yes, all the ports of the switch.
What is the difference between GI and FA? This is fast what?
No, the G1 is a gigabit Ethernet. That is gigabit, yes. It's more faster than fast Ethernet. Gigabit can send
fast.
Wait, you have 3 types. You have Ethernet ports, fast Ethernet ports, and gigabit ports.
Okay.
So fast Ethernet can send up to, Ethernet ports can send up to 10 Mbps per second, 10 megabits per second speed.
Okay.
Fast Ethernet ports can send speed up to 100 Mbps per second, megabits per second. Gigabit ports can take care of 1,000 megabits, 1,000 bits per second. Sorry. Are you getting it?
After video, we didn't percent.
You got the difference now, sir?
Oh, we just wanted to note that down, but it's okay. We'll get it from the YouTube.
Okay, so that's cool. This one takes care of only the speed of the port.
So Ethernet will transport 10 megabits per second.
Per second, that's the maximum. First 100 yes, 100 Mbps.
And GI will transport up to 1,000.
1,000 Mbps.
Thank you very much. That one is understood.
That's the difference. Okay.
Thank you, sir.
So we are done with that. So the next thing we want to talk about is the duplex and port speed. Okay, right? So you know these are all connected to different ports. Now this is the computer, and it is connected to port 1, and it's a fast Ethernet. So, but we want to reduce the speed. It's the speed is 100 Mbps. That's megabits per second. So we can go to the switch, and we have to move to the global configuration. At the global configuration here, let's change the host name of the switch. Say GRTS_switch. So that is now the name of our switch. For instance, you guys live in a story building here. First floor is GRTS, guys. Second floor is Moisey. If there is a switch in the floor, it's good you label it so that if you are working remotely, you will know, okay, right now I'm in this particular. It's also for an identification purpose. So now we have given the switch a host name. The next thing is we want to configure the speed and duplex setting of port 1. Before you can configure the port setting, you have to go into the port with this command, interface. It is a fast Ethernet port. So you're going to type interface fast Ethernet 0/1. Now you can see the prompt has changed. From only config, it has changed to config interface, that is config IF. Okay. Here now, we can change the speed and the duplex setting. How do you do that? Sorry, duplex, you can type half duplex, or you can type duplex, full duplex. This is how you mimic the duplex settings. Or you can even change it to auto. Okay? So now, I assume it is operating on full duplex. We can change it to half duplex. You can see our duplex change to half. We can also change the speed. Speed, we can put 10. Now we have changed our speed from 100 Mbps to 10 Mbps. So this is how you change the duplex and speed of a port. Any questions on that? Any questions? Hello, guys.
Yes, we're following.
Hmm? Hmm? Who is there?
Yes, we're here.
I said, any questions on that? On speed and duplex settings?
Can you just go back?
I do. Okay.
For that
Now we are done with port 1. Let's move to port 2. Okay. You have to go to the global configuration, interface,
okay.
fast Ethernet 0/2. Now we move into a different port.
Okay.
We are in port 2. We want to change the speed. Type this command speed. Let's say 50, sorry, because it can only be 100, or we change it to 10. Okay. Yes. These are the possible ones. You can change it to these three: 10 Mbps, or 100 Mbps, or auto. Okay. So we change it. Right now it's in 100. We move it to 10. We can also change the duplex settings to either full duplex or half duplex. Sorry. Okay. That is it. Okay. Yes. So you can go through the video, and then you also have, since you have your packet tracer, you try to play with it.
Yeah.
The best way to learn something is to dirty your hands with it and practice it. That is only the best way. I expect you to practice this. Even if you cannot get it right, you can get back to me. Okay? Yes. Anything extra? Hmm? So you now know how a switch will learn the MAC address and forward packets to, right? And you know how to set the duplex and speed of a particular port.